We'll go back, nerds. I already said it off camera, but now that it's in the video, I apologize for my voice quality. I did not pick up a smoking habit. I did pick up a sinus infection, though, from one of you dirty MFers. It's one of you. Maybe it's earlier in the day. Maybe it's one of the Algebra 2 people. I don't know. Maybe it's just safer to hate everybody. Okay, anyway. We're going to go ahead and finish up this lesson on periodic phenomena. So what is the definition of a periodic function? The true definition says, a function is periodic if and only if there is some number k that makes this a true statement. If you do addition and subtraction inside the argument of a function, what kind of transformation is that? Horizontal to shifting of some sort. Dilations or multiplications. So this is a horizontal shift of some sort. Basically what this says is, if you can get away with a horizontal shift and look like you did nothing, then it's periodic. That's what that says. So come back to the stuff we did on Friday. Right here. This one. It had a period length of 4. If you shift this graph right 4, you have the exact same graph. If you shift it left 4, you have the exact same graph. So because we can get away with shifting this thing left or right 4, and we have the exact same thing, we know it's periodic. Okay? And the k that you're seeing here is the period length. Because literally you're shifting left or right by the period length, and it'll repeat itself. And it could be 1 period, 2 periods, 3 periods, 4 periods. It doesn't matter. Any whole multiple of a period length, shift left or right, will result in the exact same graph. That's the definition of periodic. So this n is a whole number multiple of k, positive or negative. Here's how we write that. N is an element of, the symbol element of, looks like a C with the straight line in the middle. So this says N is an element of, that's what that means in mathematics. And whole numbers, positive and negative, those are known as integers. Draw yourself a 7, and then an upside down backwards 7. Double struck Z is what that symbol is called. That means integers. Okay? Because if n was any positive or negative or 0 whole number, then all you've done is shift left or right a number of periods. So you'll get the same graph. Okay? This says the number n is an element of the integers, a whole number multiple. It's kind of like for sequences, how the term number had to be a whole number. Same idea. Okay? Only now negatives are allowed. Here we have a periodic function. First it says, what is the period? Which is our k value. Well, you could either go from minimum to minimum or maximum to maximum. Either way, looks to me like it's a period length of 4. Yeah.
Even if the period length is 4 and I shift it by 2, it's still
No. You have to shift it a period length. A whole period length, which is why this has to be an integer. Okay? First thing we've been told to do is finish the graph. So I'm just going to fill up the rest of the numbers. Well, I know I have a maximum every 4, so 1, 2, 3, 4. That means I have a minimum every 4 also. 1, 2, 3, 4. There we go. There, we finished it. Part C says to show that this statement is true for n is positive 1, 2, 3, yada, yada, yada. Basically for every single minimum on the graph. What's the very first minimum? It's here. So here's what we know. We know f of negative 5 equals negative 2. We're now going to just add k to it until we run out of graph. So f of negative 5 plus 1 multiple of 4. That's f of negative 1. Oh, look, there it is again. That was for n equals 1. Here's n equals 2. 4 times 2. That's f of 3. Let's see, f of 3 is, oh, look, there it is again, negative 2. Just, I don't know, one more time. 3 times 4. F of 7. Yeah, there it is. Check that out. I think you get the idea. It's going to keep happening. Not bad, right? It's just showing you shift left or right 4, and you will find your next minimum. And I literally used that concept to graph the darn thing. I was like, all right, let's add 4, minimum. Let me add 4, minimum. Let me add 4, maximum. Let me add 4, just ta-da. It's pretty easy, right? That's what it means to be periodic. Now, technically, you're supposed to write plus or minus. Because it doesn't matter if n is positive or negative. Okay? I mean, you could say plus nk, and then you know that n is any whole positive or negative number. But if you're going to do it like that, then it should say plus or minus. But I'm not going to change it. Just so you know, though, when I go on to the next page, I will be writing plus or minus nk. Because it's more correct. Say it like that. Okay? Questions on this before we move on? Alrighty. In Austin, Texas, the average high temperature for each month is shown in this table. First thing we need to do is sketch a graph. My x-axis goes to 12. You know why? Because there's 12 months in a year, yeah. These are high temperatures, right? We'll graph it in red then, because red equals hot. 1,63. That's pretty close. 267. 375. 481. 587. 694. Whew, that's warm. 7's 98. We burning up. 8 is 100. Yowza. And then it starts to cool off again. September, 9th month, 93. Then 83. 72. And then 64. There, we sketched a graph. First thing we're supposed to do is describe the period of the function. What is the period of the function? It's 12, because there's 12 months. So yeah. Okay. Then it says to find the amplitude. Reminding you, the amplitude will always be maximum minus minimum divided by 2. our maximum was 100, and our minimum actually happened in January at 63. So 37 over 2. Amplitude of 18 and a half, 18.5. There. Is this crazy difficult? Not bad, right? Okay, cool. Then let's go ahead and move on. Boop, flip it over. All right. Like all functions, periodic functions are going to have zones of increasing, decreasing, concave up, concave down, all kinds of average rates of change, all of that good stuff. Okay? What's neat about periodic functions, though, is that those things will repeat, because that's what it means to be periodic. So let's take a peekaboo at this thing, and it doesn't matter if we go max to max or min to min. What is the period length? 8. The ocho. Now for amplitude, you're supposed to do maximum minus minimum divided by 2. But our maximum and minimums are 3 and negative 3. So that means our amplitude is 3. This represents a maximum. And so does that, and 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 that. This represents a minimum. So does that, and that, and that, and that, and that, and that. Because this is periodic, it will have an infinite number of maximums, but they're predictable. And there'll be an infinite number of minimums, but they're predictable, because all the maximums are this far apart, and all the minimums are this far apart. Let's get the maximums. The first maximum I see is happening at negative 6. But we know if we go to the left or the right 8, we hit another maximum. And the maximum will always be positive 3. For example, if n is 1, you get negative 6 plus 8. That gives you positive 2, and there you are. See? If n is 2, you get negative 6 plus 16, which is positive 10. So the next maximum happens over here at positive 10. It's just showing you that that's how that works. What does the what stand for? The amplitude? The amplitude is how far from the middle to the top or the middle to the bottom. Mm-hmm. Not this 3, though. This is the maximum value. This is when they happen. This is what it is. It just so happens that it's this number. This one has 3 in it more than one place. You meant this 3? Okay, this 3 is the maximum y value. Okay? I wrote too big. The minimums. Here's the first one. On this picture, it happens at negative 2. But it's going to happen every period length. And it has a minimum value of negative 3. There you go. So again, if n is 1, you get negative 2 plus 8, which is positive 6, which is up right there. So there it is. This graph has an infinite number of zones that are concave up and an infinite number of zones that are concave down, which means it has an infinite number of points of inflection. So I think it's actually easier to do the points of inflection first. The points of inflection are always going to happen in the middle of the graph. That thing is known as the midline. That one happens to be the x-axis because we're going from positive 3 to negative 3. So that means all of my inflection points are on the x-axis. Okay? So if I wanted to list all of my inflection points, how far apart are they? They're 4 apart, not 8. So all of my inflection points would be happening at x equals -8 plus or minus 4 in. The y value would be 0, but as far as the zones of concave up and concave down, the zones from up to up, how far apart are they? No, from the beginning to the beginning, 8. And if you look at the zones of decreasing, or concave, wait, that's concave down, I'm sorry. And if you look at the concave up, from beginning to beginning, 8. So the zone of concavity is repeating every period length. Concave up begins here at -4. And ended there. This says go from -4 to 8, and you're welcome to add or subtract any number of the period length that you'd like to. So if you use n equals 1, you have -4, and you could either do plus or minus, it doesn't matter, but you have to do the same one for each one. So you do -4 plus 8, 0 plus 8. -4 plus 8 is -4 plus 8 is 4. 0 plus 8 is 8. Oh, 4 to 8 right there. You see? So if n is 1, it puts you here. And concave down, that's the first one that's concave down. Right there. I haven't used any orange on this question yet. I haven't used much blue either. I'll use blue. So we're going to start it at -8, and we're going to go 1 period length times n, and this concave down zone ends there at -4. That. And for any time I had an n on this page, n is an integer. Yes, Adi. You wouldn't normally be able to say when y is less than 0, y is greater than 0. And that's because that one, for this graph, it just happens to be that when y is 0, it's changing. Okay? The whole point of the lesson is to understand periodicity, though, so it's better if you do it this way. Okay? All right. Any other questions? No. Alrighty. For this next one, since it has no curves, we cannot say concavity. But we can talk about increasing and decreasing. I mean, shoot, we could have done increasing, decreasing for this one also, but we chose not to apparently. But for this one, since there is no concavity, let's go ahead and do increasing, decreasing. The one thing that you have to remember though, when you do increasing and decreasing, brackets when it changes. Remember that? So concavity, we never use brackets, but for increasing, decreasing, we use brackets when it changes. It includes, yeah. AP likes to say, oh, that point is both increasing and decreasing at the same time. I don't like it, but I don't make the test at the end, so whatever. Period length. What is it? Looks like it's 8 again. Amplitude. The absolute maximum minus an absolute minimum divided by 2. An absolute max is 4. An absolute minimum is -3. Gives us an amplitude of 3.5. Awesome. If you cared, that means The middle of your graph is 3.5 down from the number 4. So the middle of your graph, which, again, I've told you this word a little bit ahead of time, it's called the midline, is at y equals 0.5. Okay. All right. Minimum values are going to be a trick. How far apart are my minimum values? They're 4 apart. Isn't that crazy? These minimum values are 4 apart, whereas the maximum values are 8 apart. But that's the absolute maximums are 8 apart. These are also maximums. So we'll have a maximum every 4 also. Isn't that neat? So since it doesn't say absolute maximum or absolute minimum, I'm just going to say plus or minus 4 for all of these things. Okay? Which means I can't say y equals with my coordinates. If you want to include the y, then you have to go by 8s, at least for the maximums. The minimums, since you get the same y value at every minimum, you don't have to. But to make life really, really easy, I'm just going to only write the maximums. I mean the x values for the maximums. My maximums are happening at -5, and then plus or minus, and then it is exactly 4 until the next local maximum. And then another 4, and another 4, and another 4, so on and so forth. Your minimums. First one that we can see on here happens at x equals -2. And every 4. The first interval is actually an interval of decrease. Okay? So our first decreasing interval is going to go from -5 to -2. Uh-oh. Increasing, decreasing gets brackets. Sorry. I even said it and forgot and drew a parenthesis. So we decrease from x equals -5 to x equals -2. But here's the question. What do I say plus or minus? Well, let's see. When do I start decreasing again? Is that the very next time I start decreasing? Oh, it's after the next maximum. And since the next maximum is 4 away, we can get away with doing this. So it's not 8, but it could be if I was trying to separate these longer stretches from these shorter stretches. Because from here to here is 8. From here to here is 8. So if you wanted to write it as 2 separate things, then yeah, you would be using 8. Okay? But we got lucky that we have a relative maximum every 4 and we have a relative minimum every 4. Increasing, the first one happens on this image from -2 to +1. -1, right? I said positive, but -1. And that describes every single zone of decreasing. Again, if you wanted to, of increase, excuse me, if you wanted to call them the shorter sticks and the longer sticks, well, then you'd have to say plus or minus 8 in, because from this short one to this short one is 8. From this long length to this long length is 8. But that's not what it asked, right? So we're going to be lazy. And anytime I wrote n on the page, n is an integer. So this was a special example because it had 2 minimums and 3 maximums per period. So that's special. Yes?
Will we ever need to write it like 2 different decreases?
You would only have to write it as different ones if the distance between them was different. So like say to get from here to here was 2, but from here to here was 5. So if it went 2, 5, 2, 5, 2, 5, 2, 5, and at a period of 7, then yeah, you would have to write it as separate. But we got lucky with this one that it was an equal interval each time. All right, last one. Find the average rate of change. Oh, you know what's really nice about all of these intervals they gave us? They're either an increasing or a decreasing interval. So look, from x equals 2 to x equals 3, that's right here. You can literally just count the slope, rise over run. From negative 3 to 4 is plus 7 over 1. So you have an average rate of change of 7 over 1. And x equals 3 to x equals 6, that's that decreasing zone. Again, just count the slope. Down 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. Negative 7/3. From 6 to 7, just count 1, 2, 3, 4, 5 over 1. And then 7 to 10, just count down 5, right 3. So if I had said, tell me all the zones where the graph has an average rate of change of 5, then yeah, you'd have to write it with 8 in. But I hope you don't think it's too crazy hard. Crazy hard, yeah. Good? Can I turn the page? You go on to the last? Alrighty. Word problems. Yay! A storm siren makes 2.5 rotations per minute. The sound waves have a radius of 1 mile. That means you can only hear this thing for up to 1 mile away. Mr. Tyler's house is located 1 mile south of this siren. So he is right on the edge of being able to hear this thing. The distance of the sound wave from his house varies periodically as a function of time. Okay, we're going to have to get a little creative here. And we're going to imagine that a sound has a set distance from something all the time. And I know that's not how that works, but I'm going to draw a quick picture for you. You don't need to draw this picture. I'm just trying to help you understand what's happening. We've got a siren that can only reach up to 1 mile away. That means it's in the dead center. Okay? And this siren is spinning around and around and around. So what I need you to do is pretend that the sound is traveling along this circle. That's clearly not what it's doing, but sound radiates. See how that word sounds like radius? It's not an accident. It's like when you drop a rock in a lake and the ripples will swell and grow. So every time this siren spins around, it shoots a sound wave out of it, right? But then that sound wave spreads like a ripple the entire time. until it hits Mr. Tyler's home. There's his home, okay? So we're pretending that this green dot is the sound wave and it's going around the circle. All right? So this sound wave will hit his house every so often as it goes around and around. Imagine it's like a light on a lighthouse. Okay? You know that the light actually takes time to get from the lighthouse to your eyes. It just takes a lot less time than a sound would. Okay? All right, so imagine it's like that. What is the period of the function? In seconds. Oh, you see, I was told that it goes around 2.5 times per minute. So we're going to go back to the solving a proportion ratio like we did on Friday. And we're going to say 2.5 rotations every 1 minute, but it says in seconds. We want to know how long it takes to make 1 rotation. Remember from Friday, we cross multiply and divide. And it gives us 2.5x equals 60. You divide both sides by 2.5, and what you get is 48. No. 24? Yeah, 24, not 48. I doubled it by accident in my head. 24. That is 1 period. So green dot's going to take 24 seconds to spin around. So the sound wave smacks into Mr. Tyler's house every 24 seconds. Okay? Let the x-axis represent time in seconds. We're going to go from 0 to 60. We're going to let the y-axis represent the distance the sound travels. But it's distance from his house. The siren begins its rotation facing north. And remember what it says? He's 1 mile south. So from here to here is 1 mile. So when the sound wave hits his house, how far from his house is the sound wave? 0. So then what's the maximum distance from his house? 2. So this is representing distance equals 0. This is representing distance equals 2. And it said it starts here. So this is at time equals 0. What's that? It says it starts, it begins facing due north from his house. And since he's 1 mile south, it's going to start by being a maximum distance from his house. And it repeats itself every 24 seconds. So it'll be there again at 24. It'll be there again at 48. You know what's halfway between 2 maximums? A minimum. We said the minimum was at 0. And halfway between a maximum and a minimum will always be that midline. That's interesting. How does the number 1, this is a 1, I'm sorry, from here to here is a 2. How does that number 1, what does that number 1 mean to this system I drew? It's the radius. It's the distance to the siren. It's the radius. The radius will... That's not what I wanted to ask yet, but you're not right. I mean, you're not wrong. It's exactly right. Sorry, cold medicine. What I was trying to ask was, if this is 0 and the radius is 1, There we go. Then our midline is always going to be the center of the system. For all of these circular motion models, your midline will always go through the center of the system. So Adi, the radius is 1. What does that represent in my graph? The amplitude. There it is. The radius of the system will always be the amplitude of the graph. The center of the system will always be the midline of the graph. So radius is always amplitude. Center is always midline. Always. And you know what's halfway between 0 and 12? 6. So the tick marks that I'm drawing now make this whole thing count by 6s. See? 6, 12, 18, 24, 30, 36, 42, yada, 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 yada. Because halfway between a minimum and maximum is going to be a midline hit. So with this kind of knowledge, we could actually say how often someone that is due east of the siren, like when's the first time they hear it? Someone that's due west, when's the first time they hear it? So on and so forth. And with a little more knowledge, soon we'll be able to write the equation for that system as well. But we need more knowledge. For now, I just want to know, are you cool with everything that's on here? Knowing that radius is always going to represent amplitude and center of the system will always represent the midline. Comfortable? I'm going to be real with you. I never try to do anything with these kinds of modeling questions without a picture and then a graph. I always get a picture and then I get a graph from my picture and then I answer the questions because I need to see what's going on. I can't keep it all in my mind. For example, a Ferris wheel at the Orlando Eye attraction is 120 meters in diameter. The height in meters of a compartment h is a function of time t. So the height above the ground of the thing that you get in, which I think is called a gondola, is h, where t is time in minutes. It takes about 30 minutes to make one complete revolution. One revolution. That's the period length. So it takes 30 minutes. We have a period length of 30 minutes. Let the height of the car where you enter the ride represent the height at time 0. And even though I'm aware that the gondola can't scrape the ground, if you've ever been on a Ferris wheel, you've probably noticed that underneath the gondola, because that's what those things are called, there's like a gouge cut into the ground, right? That's so that the thing you're riding in is literally at a height of 0 at the bottom. Okay? Okay. So I'm going to draw a picture because I can't do these things without them. What color should this Ferris wheel be? Red Ferris wheel? Okay. Ferris wheels have centers. What? No, that's the time it takes to go around the circumference. Okay. These will be our supports. And we hop in a car at a height of 0. Because remember, it's gouged so it doesn't drag on the ground. When you get in this thing, I'd say time equals 0. Wow, everybody's packing up. That's unfortunate because I'm going to finish this video because I'm not doing this again tomorrow. Here is h equals 0 and t equals 0. I guess you guys just have to watch the video. Anyway, let's go ahead and finish up the video. Now that everybody's gone, I can teach in peace. Except for these two that won't leave me.
Oh, don't worry, we'll leave in a minute.
You'll leave in a minute? Nyla and Julianne?
Yeah.
You'll live in infamy forever on YouTube because I'm recording. Well, luckily, it's just your voice. Anyway, so we know that this thing goes around once every 30 minutes, which means we're going to be up here at a maximum height of 120, and it's going to be halfway through the period, like that. The amplitude is always going to be maximum minus minimum divided by 2. Oh. So 120 minus Zippo over 2, amplitude of 60. It says sketch a graph of the function. Well, I just said it a minute ago, but the center of the system will always represent the midline. So that midline is going to be halfway between 0 and 120, also at 60. At time equals 0, we're on the groundish, and we know it's going to take us 30 minutes to get back to the ground because one rotation. Halfway between two minimums would be a maximum, so 15. Halfway between a minimum and a maximum would be on that purple line, that midline, and halfway between 0 and 15 is 7.5, which just so happens to be halfway between 6 and 9. And 15 plus 7.5, 22.5 is right here. So that gives us this graph. And lastly, what time does it reach the maximum? We already knew that. 15 minutes. See, I only needed a couple more minutes just so we could finish up, nerds. Thank you.